Hey everyone, welcome to Tech Talk, your go-to channel for everything electronics. Today we're diving into a fundamental component that you'll find in almost every circuit out there, the resistor. Let's understand what it is, how it works, its types, applications, and even some fun facts. A resistor is like the traffic cop of your circuit. It doesn't stop current completely, it just controls how much can go through. It resists the flow of current, helping reduce voltage levels, protect components like LEDs, and divide voltages. We measure this resistance in units called ohms, represented by the Greek letter omega. Resistors are used in tons of applications. In LED circuits, they prevent the LEDs from burning out by limiting the current. In voltage dividers, they help split voltage levels precisely. In sensor circuits, they help convert analog values like light or temperature into electrical signals. And in motor control circuits, resistors regulate speed and torque. Pretty handy, right? Resistors can be classified in many ways. First, based on how their resistance changes, you've got linear resistors, whose resistance stays constant, and nonlinear resistors, whose resistance changes with voltage or temperature. Next, we have fixed resistors, with a set resistance value, and variable resistors, which let you adjust the resistance. Think of volume knobs or dimmer switches. Now let's learn how to read resistor values using the color code system. It's like a secret language written in colored bands. Start by identifying the number of bands, usually 4 to 6. Then use a color chart. Each color represents a number. The first two bands give the base value. The third is a multiplier, and the fourth, if present, shows tolerance or accuracy. Finally, write down the resistance value with the right unit, ohms, kilo ohms, etc. Let's break down what happens inside a resistor. When voltage is applied, electrons start to move. That's current. But the material inside the resistor resists that flow, like a narrow pipe resisting water. This resistance converts some energy into heat, causing a voltage drop across the resistor. As a result, the resistor controls the amount of current flowing through the circuit. Resistors can be connected in two main ways, series and parallel. In a series connection, resistors are linked one after another, and their resistances simply add up. But in a parallel connection, the current splits, and the total resistance is actually less than the smallest individual resistor. Knowing when to use each is crucial in circuit design. Still confused? Let's try a water pipe analogy. Imagine current as water and the resistor as a valve. When you close the valve slightly, you restrict water flow. That's resistance. Just like that, a resistor controls how much electrical current can pass through a circuit. Here's a cool fun fact. Resistors aren't just for boring circuits, they can be used to make music. Yep, by combining resistors with capacitors and other components, people have built electronic instruments like synthesizers and even electric guitars. Electronics and creativity go hand in hand. Before we wrap up, take a look around you. Can you spot gadgets that might be using resistors? LED bulbs, chargers, remotes, fans. Resistors are everywhere once you start noticing. Thanks for watching. If you learned something new today, give this video a thumbs up and don't forget to subscribe to Tech Talk for more exciting content on electronics. Got questions or want more videos of different electronic stuff? Drop it in the comments below. See you next time.